So hi there. The next talk will be 5 Agile Steps to Building Elastic and Cloud-Ready Apps by ONDRO MIHALYI.
Yeah. Hello everybody. Thank you for the introduction. I'm going to talk about Agile, how to apply it not only to processes but also to your work and development of products. And hopefully, if you apply that, you would be successful in developing a product with, together with Agile processes. So first, I'm going to focus on cloud because it's probably the most complex area and also very popular these days. But you can also apply the same approaches to any projects when you develop products that are not known, or the full specification for them is not known up front, or it can change, which is 99% of projects. Even though many people think, even though many people, especially business people, think that everything can be specified up front and they really know what they're doing, they're not. And they actually appreciate if we give them something to work with and change other requirements after they see the products. But then we also need to respond to their changes, so it's good to create our application, our code, so that we can evolve it further or even change it, twist it, and we need to think about this up front. So the question now is this really about technology? Is it about all those frameworks? There are a few on my slides, but there are many more, even more cool. There are many cloud solutions, serverless technologies, like every cloud vendor have their own and very cool stuff, but the thing is that you have to learn them all before you master them. And there are older technologies like SQL, NoSQL. It's been a question for a while. And there are many more. But is it really about these things? I would argue that no. In the initial phase, at least, of your project, if you want to be successful with Agile approach and Agile development, you shouldn't think about technology too much, because the technology changes, your project changes, your requirement changes. You might spend too much time with some cool technology that you will end up not needing later. So it's good to keep an eye on these things. Like previously, there were Java frameworks popular. Even there were days where Java was very cool. Like Java was the language, the new thing, and everybody was talking about it. These days, everybody talks about these K words like Kubernetes or Knative. They're all so cool, but the problem is they are new and not many people know about them. But if you're not careful and try to dive too much into the technology, you may need to use the F word, which I guess you don't want, really. So it's good to think about our users, what they need, and to deliver something to them quickly before we screw up, diving too much into the technology, spending too much time there, and in the end realizing that our users just don't expect us to release things because they don't understand them. They understand the final products. They want to see them, touch them if possible. So it's good to think about these things. But to make ourselves successful, we also still need to think about technology or technical things. But what's more important than technology is the architecture, the structure of our product, how we build it, how we assemble pieces together, how we think about it in the future, how we plan its evolution. Because very often we need to change things, and it's good to prepare for the change. Some people say that the change is the only constant, so it's not a good thing to ignore it. So for modern applications, which especially aspire to be deployed in the cloud and be successful running or serving many users, we need some kind of persistence. It was always there, but now if we want to be flexible, it needs to be pluggable. So it's good to abstract it and start with something simpler and then observe other things, other solutions. Maybe we really need this, that Amazon Dynamo database or some crazy NoSQL database because it's very performant. But my message is we don't need it now. We should evaluate it, but use something simple to build a product, to show it to the customers that just with small features, to have them evaluate that product. And while we're waiting for customer feedback, we can explore other things and already think towards the future. But we're prepared to change things. We need to build our application so that it's easy to scale in the future. If our customers plan that only 500 people will use the application, and then in a year time, he will figure out that there will be 10,000 people using it because the business grows. It's not good if your application can't scale. You would have to refactor a lot of it or just start from scratch. So it's good to have this built into the application. And to make this possible, we need to decouple pieces of our code. We need to build separate components which can be scaled separately, which can be assembled in different ways. And we also need to configure them. If the number of components starts, we might need to assemble them as different services, potentially microservices, and potentially lots of them, although there are not so many companies who really do these hundreds of microservices stuff. But still, even with a handful of services, we need to configure them, and the best way is to configure them somehow centrally so that we can spread the configuration. So it's good to have some way to externalize the configurations of the applications that consume it, and you can push the configuration to them. With the increasing number of services, you also have communication between them across network, so we have to recover from failures, especially from network, because in the process and in operating system there are far fewer failures than on the network. It's completely different scale. Then again, also security is more important, because now you're on a network and everybody can see who has access to the network, can access the communication, which is far easier than if they had to hack into the computer which runs the application and to somehow scan the memory or the operating system resources. And then monitoring is also important, because if you have a lot of functionality scattered around the place, you also want to have something where you can monitor things in one place and not log into every service and see the logs and somehow try to put all those logs together and be crazy about it because it takes too much time and goes nowhere. So is there a solution to this? I would argue that yes. I would like to show you how you can apply agile principles as we know them from processes, from development of our applications, like meaning organizing the teamwork. You can apply the same things in development, in the structure of the application, in the architecture. So in the same way as we build very, very small, or I recommend from my experience, it's good to build a small framework for agile processes, not to adopt a whole Scrum, but just take the pieces that work for us and later adopt more and more once we perfect them. It's also good to take good pieces from Java libraries and technology we have. And the best way to do that is to take widely used abstractions that we know are supported by many libraries, many frameworks, are here to stay because many people use them, many people evolve them. And if APIs are successful and specifications are successful, they have many implementations, so it gives you a choice. So it's another layer of flexibility. You don't need to change the API because it's quite powerful already, many people work on it. But you also have a wide range of implementations, wide range of options. And you may find something useful in the early stages of development, something better for production, something better for testing. Sometimes it's even useful to use 2 or 3 different implementations for different services. because for one service you want to make it fast, for the other service you may want to make it robust and easier to monitor and control. So it's good to choose some useful APIs, but that's it. The rest is focus on the logic, on the features, and deliver them to the clients as fast as possible to gather feedback from them. Then you can improve the technology. If you have good abstractions, you can replace the less performant parts or less sophisticated parts for something better. But if you don't plan that, you either start with very hard to use technology and it takes a long time to deliver something to the client, or you start with very simple technology and then you have to rework everything if you don't prepare for plugging in the more robust pieces. So pictures say more than 1,000 words, so I used the picture to envision what are areas we should think about when designing our application, especially if we want to plan for scalability in the future. Even if we don't need scalability, it's good to plan for these things, to decouple our components, and in the end, maybe we will just deploy them in one application, but we don't know that up front. And it's a good way to keep doors open towards extensibility, towards growing our application. It's like Lego pieces. Everybody likes Lego. It's so easy to play with because we just take some pieces, assemble them together. If it's too small, you can just take pieces out and put more pieces and shape it towards the liking. And the end product is almost always good. Even a child can create something that looks nice, because Lego pieces are very, very nice and very beautifully crafted, and they fit together very well. So it's something like what we should seek in our applications, in our architectures, to assemble high-quality pieces that work well together, but also be prepared to remove them and replace them with other pieces. So we usually want to scale our services, or at least prepare for it. It's also important to think about databases. That's a thing that usually we want to scale later, either for scalability or for robustness, to prevent data loss if database node goes down. So it's good to have data distributed and replicated a couple of times. And it's also good to have a distributed message broker. So I'll start with the first area, which I would like to recommend you to consider when developing new applications or refactoring older applications. If you start practicing more agile development, and one of the useful things is caching. And caching is an area which many people think is quite on the border of what we would need. Mostly think about cache when they want to optimize some access to database. But caching is interestingly also an API that provides you some sort of persistence. You can put something to cache and it stays there for some time. During development, it may seem only even eternity, because you just started an application and work with it a couple of hours, and until you put it down, it's still there. And many caches are distributed, so you can start multiple instances of your application, or even just empty instances of the cache, and keep them running. And then it works as a database. It's just in memory, but as long as you run it, it's still there and you can work with it. And Jcache is an API that abstracts these caches with an API that's been here for a couple of years and already has some like 10 or more implementations, so you can choose. Some of them are distributed, those are which I recommend. Some of them only run in one process. These are more just to get started or do some very simple tasks. But the distributed caches are what you should be looking for, because you can then add more nodes and turn the cache into some sort of persistence that never goes away, even if you stop your application. And as long as at least one node of the cache is running, the data is still there. So you may start with caching instead of database, because it's easy to install. You have all those 10 or more implementations that I was talking about are based on Java. They can be embedded into our application as a library. You can just start them. They connect to other nodes in the cluster on the network. Very often there's automatic discovery, so you just either try if it works. If it doesn't, you give it some hint to find other nodes in the cluster. But then it works fine. You just can use it as a distributed map or basically data store, key value store, I would say. There's not much querying compared to NoSQLs, but you still can find the data there very easily, especially using the key and querying the keys. And if you need something more, you can plug something or use something specific from your caching provider, which like every implementation provides their own APIs, so you can then use the API of the library, or you can build or abstract them with your own APIs. Like always, when you use a library that is essential or may happen to be essential in the future for your project, it's good to think about abstraction. So not use the API directly, but at some point in time, it's good to think about creating a layer, an interface, which somehow hides the implementation details and only exposes what the application needs. And then you can easily replace things and modify things behind the curtain. The JK's API is very simple. It's basically, it has two forms. It's either annotation-based or programmatic. So in frameworks or environments which support some kind of annotation parsing, most Java, it fits well with Java servers, which have a CDI container, which easily can scan all the annotations on CDI beans and turn on interceptors for these annotations. But the same API also works with Spring, because it's just annotations, and Spring is also a container, it can discover them, and there is support for JK's API too in Spring. But you can also use the programmatic API. Either you can inject the cache object or get it with a static method, and then you can just work with it so closely, similarly like a map. It's a different interface because it's optimized for speed in a distributed environment. So that's why it's not so easy to iterate or get all the data in a cache, because there are potentially a lot of data and you don't want to get them on one node. They are distributed across the node, so some piece of the map or the cache is on one node, some on another. They are usually replicated, so if some node goes down, you still have the data and it distributes. But you don't want all the data on one node because it would take a lot of memory. So there's split iterator with which you can iterate over the data. It makes it easy to get the data one by one and somehow filter them, but it's not a good approach to get all of them on your site. One example, really nice example of JK's implementation is Hazelcast. It's supported by most containers I know about. There's Spring Boot. Spring Boot is nice that it has support for many different implementations. You just plug them in. In application servers, it's also possible, but most of the application servers choose one implementation to really integrate it very well into the features. And Payara even goes further and uses it for distributed HTTP sessions, for session replication. And also to send messages and communicate across clusters of many internal stuff is based on Hazelcast. Because once it's there, it connects every node together, so you can have overview and control every node in the cluster very easily. And the advantage is that it can grow and shrink very dynamically. So you just start a node and it connects to the cluster. You don't have to configure anything. The second thing, to extend what we have, or basically get it up and running, is to have some decent runtime. It can be a framework where we assemble pieces together, or it can be an application container. I prefer the word runtime. Like Java runtime, it's a virtual machine environment onto which you basically deploy applications written in Java. And into runtimes you deploy applications that use the runtime APIs and its functionality and basically run on top of it. It doesn't really matter if you use the runtime to start your application or your application starts the runtime. There's always some part of your application is controlled by the runtime. So I already mentioned a few runtimes. Spring could be perceived as a runtime, although it's also a collection of libraries. Spring Boot is more like a framework that assembles pieces together and builds a runtime. There's Payara Micro, which offers a lot of common APIs like Microprofile and Java EE, so you can get quickly up and running. It's just a jar file. You don't have to pull any dependencies. Everything is there, and it's not big. It's around 70 megabytes with all the features, and even a lot more than the APIs. Java EE was recently renamed to Jakarta EE, so I'm replacing the icon here. From now on, you just have to remember that future Java EE is called Jakarta EE. If you want to know more, there's a panel at 1:30 where lots of experts involved in the specification process and in implementations of Jakarta EE and Java EE APIs. They will be there, and you can ask them questions, and they will, including me, I will be there too. We will answer questions and explain the current status and what you can explain in the future. But there are also more implementations. As I said, these are specifications, so they all have different implementations, and you can choose which fits your needs better. So the advantage of runtime, I'm not going into details about Payara Micro. The advantage of runtime is that you already have a lot of setup for you. So in the initial phase of the project, you just use it to write something from scratch, to experiment, add JCache API implementation, use it. With Payara Micro, you even have JCache integrated, so you don't have to pull any dependency. And you just start your application and focus on business code, business logic, and try to deliver something quickly to the customers, to the clients, so that you get feedback from them, and don't waste your time doing something they don't want. Maybe I'll talk something about Microprofile. I don't know, how many people know about Microprofile or heard about that? It's not so many. I would expect more. Is there somebody who knows the specifications of which APIs are in Microprofile? Yes, a couple of, but not many. Okay, so it's in short, it's another set of API next to Java EE. Which is created collaboratively by many people involved in Java, especially in the enterprise world. Many of those involved are behind the application service, but now I prefer to use the word runtime because application service evolved very rapidly into much more flexible things than they used to be. And we work together to bring a unified set of API for everybody to use, but without being stuck with one vendor, one implementation, and you can choose what fits you well. And the focus is on modern technology. So the difference between Java EE or Jakarta EE and Microprofile is that Microprofile is not tied with any process. We only have a lightweight process which we developed ourselves. So it's not a real specification. Nobody approves that, only the community. We vote and talk about it. But it's still binding. Like all the people who work on it promise or even do keep their promise to implement the features, provide them in the best way possible, and come back to the specification to fix it if there are some problems. And we are open to community, so we value every feedback. If you haven't tried Microprofile, just give it a try. Try to learn the APIs, the functionalities it covers. It's very lightweight, it's easy to start, and it provides a lot of APIs, like here on the picture, but they are small compared to Java EE specifications. They are much smaller. Like normal usual Java EE specification document is like 100 pages, and Microprofile specifications is around 10 to 20 pages, and it's very much more informal than Java EE, but it's still, it covers whole functionality. If we miss something, you may raise questions or a few comments, and we'll try to fix it as soon as possible. There are releases every 4 months, so we can improve very quickly. So I'll continue with the third approach. You could say that it's technological stuff. I called it RESTful, but it's not, again, not about technology. It's about calling services, the communication. And the cool thing about REST is that it's already here. Most of the people are familiar with it. Most of the people use it. It's widely supported by many frameworks. So it's almost seamless to use it. Everybody thinks about RESTful communication when they talk about microservices, although there are other, even better ways. But to get started, RESTful is the best choice. So here's where it fits between the services when you want to connect them. It's a little more complicated because to find services, if you have many of them, you also have to have some form of service registry where services announce themselves when they start so that everybody else can find them, because it's point-to-point communication. You always have to know whom you're talking to, or you're talking to a proxy that forwards it to somewhere else. So you have to know something about the topology up front. But it's very easy to start with. Here's an example of common REST API from Java EE. It's called JAX-RS, Java API for RESTful services, or something like that. It's also supported by Microprofile, so there's a bit of overlap. Microprofile adopted some specifications from Java EE, which were useful. But what is nice about this API, and you can find it in many other APIs, is that it maps methods and objects to REST requests, and also to different forms of payload. So you can basically write Java code and just create some mappings to the REST request. And this is important because then you can extend it. You can take the code and run it somewhere else. You're not tied to the REST protocol. If you need to change the protocol or reuse the code, you can just copy it somewhere else, change the annotations, the boilerplate, but the logic stays there. So once you wrote the logic, you don't have to modify it too much to change the technology underneath that powers the logic. On the other side, the client API is not so nice. It's more low level. But in Microprofile, there's another API that's built on top of it, and it basically provides you ability to write an interface. So you define what you want to call, but not how. The how is provided by the same mappings as we use here. It's just reversed. So the end server mapping is used to by container to find out how it can map REST protocol to Java calls, but it can also be used in the reverse way to map a Java call, a method, to a REST request, and then back REST response into a Java return value. So that's again nice, because if you write Java, you can reuse it anywhere. If you write something specific to some format like JAX-RS client API, it's much harder to take it and refactor, because you have to refactor whole things, or you have to abstract it so that you can refactor later in the future. JSON binding is another example of a useful API which fits well with Java2Days or any other REST API, because it provides the other part of REST, which is the mapping of the payload. You don't only call services, but you also send data or receive data. So you have, and this is still in textual format. And mostly we use JSON these days. Previously we used XML. It's possible to use both with Java2Days, but JSON is much more popular. And JSON binding is a new specification in Java EE, which you can use to fully bind any Java object to JSON. This is how it looks like. Similar to JPA, if you know it, it's just some annotations which you add some information which isn't there in the class. Some classes, simple classes, can be mapped to JSON straight away. You don't need any annotations, but if you need to modify how they are mapped or add more complexity, like children collections, then it's useful to use JSON binding. Yeah, so that was communication. Communication is not always easy, because you still need to scale the communication. And imagine in the real world, you have only one phone and you can call one person. So what do you do to talk with more people? You text them, you chat with them, and you can chat with as many people as you like. Like while waiting for a response from one, you can chat with the other one. And the same can be applied in programming. So to scale the communication, we sooner or later need to jump to asynchronous communication, to messaging. Just to send messages and don't wait for acknowledgement. The services would either ignore us, it's also fine if we don't need an acknowledgement, or we'll acknowledge later at some point in time. But meanwhile, we can communicate with many other services. And I want to show you how to use a very simple thing in existing APIs, which is CDI. CDI contains a small part of API which supports sending events. But the thing is, with CDI, you can only send events within one process, so it's not very useful to communicate across services. But there are ways how to catch all the events you send and transfer them to another service, especially if you already have something like Hazelcast or distributed cache that supports sending messages across queues or topics. Then you can very easily build a mechanism that catches events in one process and sends them to all the interested parties somewhere else. And it's very, very easy to catch events, to build this. It can be done with a CDI extension, just maybe 100 lines of code if you already have the technology. And the technology is already there. You can use Hazelcast or any form of in-memory data grid, and you can even extend it to more complex technologies. But there is a catch. CDI events don't offer everything what we would expect from messaging. So basically it only offers sending events, and there's no reliable broker. There may be if you use a reliable broker or something that works behind the CDI events. But it's not easy, and what's not easy is transactions. You have to build them yourself, because normally it would require a lot of plumbing to integrate with CDI events. But the good thing is that initially you don't have to care. The Agile approach is about trying things, creating things fast, deliver them to people, and later improve. So maybe you're thinking about transactions, but doing something very simple and still thinking about it, would you do it in the future? But you only do it when you have a confirmation from your client, from the customer, that what you're doing is right and we want to go that direction. Because otherwise, it may happen that you will ditch the project and you will do something else, or you would have to completely recreate a lot of what you've done. So it's good to think about things, but delay them to later time when you really know that you will be using them. So initially, in development phase, you really don't care about data because it's just fake data. If you lose them, if transactions don't work, that's not a big deal. As I said, Payara already has Hazel cars, and it makes it easier to integrate with CDI. But Payara even went a bit further and provided that integration for you. So if you happen to be using Payara Server or Payara Micro, it's already there. You can use both JCache, but you can use also distributed CDI events, and it works with just two more annotations. One is on the sending side, so if you trigger events, you have to mark the event with outbound annotation, and on the other side, you observe the event with inbound. And these two pieces of code are in two different applications deployed into different services. But it's that easy to bridge these services from one CDI event, with one CDI event to carry to another service. If we continue this way, we may see that it's quite nice that we like the concept of throwing events. We don't need much more. We just need a more robust solution in dispatching the events. So now we're in the phase where we need to focus on transactions or securing delivery of messages. And we might need to replace the CDI events, or even better, I'll come back to it soon. You'll need to use some kind of message broker, but in the modern world you wouldn't use JMS or traditional brokers. You would use what your cloud provider offers to make it fast next to your application, or use Kafka either on local machine or even in the cloud. Or there's also a popular protocol called MQTT, which is very often used in IoT, so in between devices, different cloud. It's not what we have from Microsoft or for Amazon, but there are clouds provided by different companies where you connect a lot of IoT small devices and they communicate to each other and send information to the cloud. So there's a way how to integrate all these formats or all these protocols into the common API, into our containers, into our runtime, and it's called JCA. JCA is a low-level thing which allows was created basically for plugging in different JMS providers. So you could use it to bridge technology and provide JMS messages. But for those technologies that don't provide easy binding, it's still possible to use this technology to come up with something similar to JMS. So you would still have something conceptually similar, where you have a message-driven beam, which is just an object, or basically a listener, and you configure where it listens, and it just triggers, the container just triggers the method, and you're done. You do the business logic in the method, and then again, you end up with a reusable code, which you can take and use anywhere else. Here's an example of how it looks with Kafka. The thing is, it's not standardized, it's only vaguely standardized based on the standard technology, but the API is from a project called Cloud Connectors. And they have multiple connectors for many different message buses. But it's more like a proof of concept, but you can either use them or build your own. What is important is you don't have to replace your CDI implementation with JCA connector. You can make them work together and evolve your application. If you start with something like this, you have an event thrown by one service and observed by another service, you can replace the mechanism how the events are dispatched with your custom mechanism, and you can use these JCA connectors which are already there, or you can build your own, or you don't even have to build JCA connectors. It's just an example how you can plug some technology inside your runtime. But the thing is, it's useful to think this way, just to extend your application, to build it for extensibility and then just fill the missing pieces. In this case, we first cared about throwing an event and dispatching it somewhere and getting it somewhere. And we didn't care much about how it's going to be dispatched, how performant it is, how reliable. Now, once we start thinking about these things, we can replace the mechanism, but the API can stay the same. And CDI events allow that. There are many other APIs which allow that, but it's important to use APIs, not really the client libraries, because then you have to replace a lot of code. This leads to, or this is an example how you could evolve your application in the way how it was envisioned by ThoughtWorks consultants who focus on this area. And they basically describe evolutionary architecture as a way how to make or prepare applications for continual change. So that you create your application and you're able to modify it easily without too much cost later on. And as I said, there's almost 100% sure, it's almost 100% sure that changes will happen and you will have to adapt, so it's good to be prepared. By the way, microservices are mentioned by these guys as one of the architectures that meets these requirements. There are other architectures, or you don't even have to follow architectures to meet the requirements. But what microservices have in common with these architectures is they separate the logic into components. Another approach is to start with domain-driven design and create separable components, but you don't have to split them to services. Maybe later you will split them to services if you need that, but it's good to keep pieces of code separate and clearly design the interfaces between them. And the last thing I want to mention is configuration. Configuration is very simple if you think about it, but very hard to do well, because there are many approaches to configuration. There's nothing like log4j for configuration, so nothing's fairly standard. But it's good to have an API where you can just get some information. You don't care, like you don't want to have constants in your code. You don't want to have magic numbers. You don't want to have code that reads configuration from file. What if you will need to read configuration from a database or from an environment? So it's good to externalize this and just use some API that says, I need this value. I don't care where it comes from, I just need it. And this covers the gap in, or helps you to write complex stuff in a simple way. And until recently, there was nothing you could use across all the applications. But within Microprofile, one of the first specifications was about configuration. And it's one of the special specifications in Microprofile which you can use separately, individually with any framework, because it supports plain Java. It's also easy to use with dependency injection. You can inject values, but you can use plain Java code to call static method to retrieve the data and configure everything, including configuration sources which you can plug in later on. So you don't have to think up front, you just use the API, and later when you realize that you need to change the source of configuration, you either plug in something existing or you can build your own. It's just one class that you need to implement and one small textual file to register it. Currently, in the standards, Microprofile configuration supports environment variables, system properties, and property files in the application. So if you use these, every implementation should support them. But you can also plug in other sources, as I said, for reading data from database or reading secrets. many cloud providers have a service that provides secrets like passwords or accesses or private keys to secure the communication. And there are some sources provided by the runtimes which go beyond what is required by the specification. On the right side, there's how it may look like in the code. So with dependency injection, it does inject a value. A lot of classes, a lot of types are supported. Basically, almost everyone, like not only standard ones, but any object that has a constructor that accepts string, any object that has, or class that has static value, I think parse, which accepts string or toString or from string or something like that. A lot of options. So basically, a lot of existing classes or even your classes are supported automatically. But you can also write your own converters if you want to, for example, support list values or more complex stuff, because in Microprofile config, the basic building block is string. So every value is a string essentially, and then you need to convert it to something else. I'm here I'll continue with the demo. I have maybe I'm a bit out of time, but I started later. So I'll show you just example how you can use the evolutionary approach to extend asynchronous communication from a CDI to a more reliable broker. So here I have an application which is very simple. I hope it works or it stopped. I think I need to refresh. Come on. Is it running? I'll just restart the services because I think hibernation didn't help them. Oh, this here. So just a small example in the code where one service basically sends an event, which as I said, is just an annotation on an event. Later in the code, you use the injected object to fire the event. And all you need is to add this outbound annotation, which is provided by Payara. It's specific to Payara, but I'll show later how you can extend this to more portable code. And then, basically on the other side, you just observe this. So this is a different service, different project. I started 2 different services, and hopefully everything works. No, it doesn't. Oh, I got a different host name. Wow. Let me try this. Yes. Here it works. Here we go. So the first application is generating some random stock price, and the other application is just showing it instantly on the page. So in between the services, there's Hezoka sending one event to the other server. The event objects have to be serializable to allow that to happen. That's the only restriction. And then server send events are used to send data to the browser. So nothing really complex. It's just one annotation and 2 or 3 lines of code. But it's also quite easy to extend this to Kafka, to use Kafka as a message broker. I'll just open, you can see that there's blank screen. This is a view of Kafka topic. There's nothing in there. So you can see that I'm not using Kafka. But I can easily switch to the implementation to Kafka. I already prepared code that sends data to Kafka. And here's the code that receives the data. So some configuration to access data and map the data from text to Java object. And then when I receive the data, I again raise the same event. But this time it's with Kafka qualifier. So basically in the previous code, the only thing I need to do to trigger this on is to change qualifiers. And this is an instruction. Here it instructs the container to not send the event to the Hazelcast cluster, but send it to my listener here in the Kafka publisher, and this listener gets the event and then sends it to via JCA API to the Kafka broker. And on the other hand, I need to change this. The place where I receive events with inbound, I again replace inbound with my Kafka qualifier, and here's where I use it. I use it to raise a Kafka event, or even with Kafka qualifier. And that's it. I basically changed 2 different lines, and I switched the implementation, and all the rest of the application works. I just needed to create 2 more classes to implement the communication with the Kafka broker. Now when I start the applications again, it'll take a couple of seconds. I think we're almost there, almost there, almost there, almost there. Are we there yet? Okay, we're there. So the application didn't change. What changed is we now get the messages through Kafka browser, so we can observe them in the queue. They're really in Kafka, and it's more powerful because you can scale Kafka much better and across network, and even keep the data on the disk compared to Hazelcast. Hazelcast is also good to scaling because it's in memory, it's fast, but with Kafka you have the reliability and acknowledgements and more robustness. So this is how easy it is if you plan up front, if you're prepared for change and externalize the technical stuff. Yeah, so basically I'm done. I'd like to show you more, but just mention the last thing. That's a bonus. You get monitoring. If you use a decent runtime, you get a lot of monitoring out of the box, because the runtime is a compact tool which not only provides you APIs, but it understands your application. It knows when you call the API and can monitor how often you call things and expose them with some interface. And within Microprofile there are 3 specifications that cover this, that unify the way how this data is exposed. One is metrics for general monitoring, then there's health check, just yes, no status, if the application is healthy or not, and probably needs to be restarted. And then open tracing, which instructs applications to add more information to requests, to be able to find all related requests. So usually it adds an ID on top of request, and all the requests which are relevant share the same ID. So in the logging, in the analysis later, you can see how the request triggered another request and the sequence, how it went. There's a lot more, either in runtimes or in the standards. I recommend you to look more deeply into that. And I'm happy that you attended my talk. I think that's it. I would like to ask for questions, but I probably don't have much time. So if somebody's really interested in questions, raise your hand. Okay then, so I'll leave the stage for another speaker. Thank you very much.